Dear students, welcome to the introduction section to Z transform. In this session, we are going to learn the basic definition of Z transform and some few formulas and properties. Let us go into the session. The unit consists of elementary properties of Z transform, inverse Z transform, initial value and final value theorem, convolution theorem, and finally solution of difference equation using Z transform. Before going into the session, let us know few informations about Z transform. The Z transform was invented by a great man, Elia Ibrahim Zuri, from 1923 to 2020 September 20. He received his EE degree from the Technion Israel Institute of Technology, IFA, in 1947, and he got his MS degree in electrical engineering from Harvard University, Cambridge, and MA in 1949, and SCD degree from Columbia University, New York in 1953. He was a full-time professor in California University, Berkeley, and University of Miami. He developed the advanced Z transform used in the digital control systems and signal processing. He was the creator of the Jury stability creation, which was named after him. So he was a great person, and we are going to study what is meant by Z transform and what is its application, how it is helpful in solving difference equation. And many electrical applications are there where you can study in your core paper. And this is the portrait of Jury created by an AI. This is not an exact image. AI created a good image which is portraying him. Now let us take a function f of n. It is going to be a sequence, first of all, defined over n equal to 0, 1, 2 up to infinity. Then the Z transform is defined as n equal to 0 to infinity f of n into z power minus n. This is called as unilateral Z transform because my n values start from 0 and it goes up infinity. Suppose if my n values start from minus infinity and it goes to infinity, it is going to be bilateral Z transform. Then the another version of Z transform, when you take f of t be the sequence where t is equal to 0, capital T, 2t, 3t, etc. They are the discrete values. Then the formula is defined as summation n equal to 0 to infinity small f of nt z power minus n. So this will be helpful for your MCQ purpose. This is the another definition. Bilateral Z transform, as I said, the only change is n varies from minus infinity to plus infinity. So throughout this chapter, we always use unilateral Z transform. That means my summation varies over 0 to infinity f of n z power minus n. So z of f of n. So my input is going to be n and my output is always going to be Z. Here, very important, this Z represents the Z transform and this represents the small z. It is a function. So my input is n, my output is z. Therefore, z of f of n is known as capital F of z. These are all some basic formula which you already studied in semester 2, which we are going to use in this chapter. So let us see one by one. We know all these four formulas which we used in our school days. In addition, we have few more formulas. Minus log 1 minus x is x plus x square by 2 plus x cube by 3 plus x power 4 by 4, etc. E power x, it is very obvious, it's known to you. So using these formulas, we are going to find some basic properties, some calculations. So let us go into the problems. We are going to find Z transform of some elementary sequence. Whenever we take a transform, Z of 0 is obviously 0. And we have a curiosity, what will happen? Z of 1. What will happen? Z of n, because input is n. What will happen when I put 1 by n? When I put 1 by n factorial, etc., etc. We are going to see everything one by one in this session. Let us go into the first data. To find Z of 1. Now we know the formula for Z transform, but always I prefer 1 by Z power n into f of n. This is easy for computing. Now I can write like this. Since Z of 1 means the meaning is Z of f of n. Therefore, my f of n is going to be 1. Now if I substitute here, this will become 1 by z whole power n. When I put n equal to 0, I'll be getting 1 by z plus 1 by z square, etc. It goes up to infinity. And we know that this formula is nothing but 1 minus 1 by z whole power minus 1, because the formula says 1 minus x whole power minus 1 is 1 plus x square, etc. if mod x less than 1. Therefore, my answer is going to be 1 minus 1 by z whole power minus 1. Simplifying this, we'll be getting z by z minus 1 as my final answer. Therefore, z of 1 is small z by z minus 1. Next, we are going to see a power n. What is z of a power n? As usual, take the formula, substitute the value. Here, f of n is a power n. Now, here a power n, here 1 by z whole power n, both the powers are same. I can club this together. Now, if I expand this, I'll be getting 1 plus a by z plus a by z whole square, etc. up to infinity. So I can use the same formula which we used in problem 1. I can write it as 1 minus a by z. Taking LCM and simplifying this, we'll be getting the answer z by z minus a. So ez of a power n is gonna be small z by z minus a. Now you see, if a equal to 1, it will become 1 power n. 1 power anything is 1. It's going to be 1. Therefore, it is going to be z by z minus 1. Next, they may ask some MCQ. What is z of 2 power n? You can write z by z minus 2. What is z of 3 power n? It's going to be z by z minus 3. Sometimes they will ask, what is z of minus 3 whole power n? See, the general formula is z of a power n. That is going to be z divided by z minus a. I don't bother whatever it is my a. So now if my a is minus 3, then it is going to be z by z minus of minus 3. That is z by z plus 3. Hope you understand. If you are positive, you will be having minus 2. If you are negative, you will be having plus here. That's it. These are all some MCQs they can ask you. Next, let us go into the derivation for z of n. As usual, we take this formula. Now, what is the extra data? I have n here. So now when I substitute n equal to 0, it will become 0. Then 1 into 1 by z, 2 into 1 by z whole square, 3 into 1 by z whole cube. It goes on. Now we see we don't have formula for this. But I have a formula. 1 minus x whole power minus 2 is 1 plus 2x plus 3x square plus 4x cube, etc. But here 2 power 2, 3 power 3, 4 power 4, 1 power 1. Now if I take 1 by z outside, it will become 1 plus 2 times 1 by z, 3 times 1 by z whole square, 4 times 1 by z whole cube, etc. Now you can see this 2 power 1, 3 square, 4 cube. Now it is eligible to apply this formula. If I apply this formula, I'll be getting 1 minus 1 by z whole power minus 2. So already 1 by z is there. If you take LCM, z minus 1 by z whole power minus 2. So 1 by z. If I take the reciprocal and square it, it will become z square divided by z minus 1 whole square. So it is going to be z by z minus 1 whole square. You can see the typed version. Therefore, z of n is going to be my z by z minus 1 whole square, provided mod z greater than 1. All these formula, students, we are going to use in inverse z transform. Next problem is z of 1 by n. In this situation, I cannot go n equal to 0, because if I put 0, it will become infinity. That's why it is clearly given n greater than 0. So for this formula alone, it will work for n equal to 1 to infinity, f of n z power minus n. This is a very special case. Even though the general formula is 0 to infinity, for 1 by n, I don't have option. I have to take from 1 to infinity. Next, substituting the values 1 to infinity, we'll be getting like this: 1 by 1, 1 by z, 1 by 2, 1 by z whole square, 1 by 3, 1 by z whole cube, etc. Now if I take this data alone to the numerator, I can see the formula like x by 1, x square by 2, x cube by 3, etc. This is nothing but minus log 1 minus x. So now minus log 1 minus 1 by z. Taking LCM, we'll be getting log z minus 1 by z. Now if you take this minus to the power, we get log z minus 1 by z whole power minus 1. And simplifying this, that means making reciprocal, we get the final answer. Z of 1 by n is going to be log z by z minus 1. This is my answer. And in forthcoming videos, we will see more formulae.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.